Let's find out more about the next branch of AI, which is robotics. In the field of robotics, scientists try to create computer systems that replicate human actions. A typical robot consists of a central processing unit, sensors, actuators, end effectors, power supply, and a control system, which is known as a brain, to perceive the environment around it, process data and information, make decisions, and then take actions. But how can robots learn to do human tasks? How can you train robots to do complex tasks within construction site? Before then, let's look at the dog training example. To train a dog, we use the positive reinforcement training, which is about rewards. So we give dogs treats, praise, or toys for desired actions that they're taking. Like dogs, robots are not naturally programmed to take the actions that we desire. After all, they're machines and have no intelligence. However, we can teach them to perform tasks through repeated trial and error. One of the most useful techniques for training robots to make a sequence of decisions to perform tasks is reinforcement learning, which is one of the sub branches of machine learning and one of the most useful machine learning methods to train robots. It consists of an agent, an environment, observations, actions, rewards, and policy, or known as function. In reinforcement learning, an agent interacts with the environment and learns based on rewards or penalty signals. The agent explores and collects the data from its own actions and experience and maps them to the received rewards or penalty signals, like a trial and error approach. The agent uses the received reward or penalty signals as the performance metrics to learn the best actions or behaviors within the environment. Otherwise, without the performance metrics, the agent does not know what is good or bad. Once the training is over, you need to validate the train policy, which is simply a function telling the agent or your robot what action to take in any position that it is located. If you find the mistake or error, you need to retrain your agent or your robot. Let's look at an example of reinforcement learning in construction sites. Let's say you want to fly an autopilot drone over the construction site to record all activities. You can use reinforcement learning to train the drone to navigate the optimal and safest path within the construction site by itself. But how can you do that? Imagine this entire construction site is represented as a 2D grid with obstacles within that grid, like your crane, buildings, or materials. The drone, as an agent, flies over the construction site to reach the target location while avoiding obstacles. It will start from the starting point and can perform 4 actions within this grid that you created. It can move up, down, right, or left. Let's look at it here. So here, the drone is moving up, down, right, or left, and it receives reward or penalty for each movement. Receiving a positive reward for moving closer to the target cell and via the safer zone, and receiving negative reward for moving further from the target cell or entering the banned cells. So the policy here defines that the drone should avoid red cells under all circumstances, and it can enter the black cells, which represent our building. If the drone mistakenly enters the red or black cells, then it has to start over, as you can see it here. During the training, based on the received rewards and penalties, the agent learns to navigate the 2D grid and reach the target cell via the optimal and safest path, which here was option A and B. Once the training is over, you need to verify the results and evaluate the agent and train the policy. If no issue, then the drone should be able to navigate to the target destination within the real construction site that you want to fly it over.